Rachel Sheet suffers from diabetes. As a result, she struggles with chronic inflammation on her legs that simply will not heal.
I had a large wound, and the doctor come every week and checked it, and he did several different things, and it would heal a little bit and then it would stop. And then it would heal a little bit with some other thing to try and it would stop again.
Many patients suffer from the same problem. Diabetes attacks vessels and nerves, and chronic ulcers or wounds frequently form on the legs and feet. Unfortunately, they're often untreatable. Sometimes the doctors have only one option left: amputation. In Germany, this is the fate of 40,000 patients every year. Worldwide, an amputation takes place every 30 seconds. Now, there is a completely new therapy that could prevent this terrible procedure.
We developed what we call a decellularized dermis, and when that decellularized dermis is applied to these chronic non-healing wounds in diabetic patients, just one treatment has found to give extremely good results.
We put in a biological scaffold or a decellularized tissue, and then the body repairs and regenerates that by a natural process.
The University of Leeds in England. At first, the research by Eileen Ingham and John Fisher had little to do with the fate of chronic wound patients. The scientists were simply looking for a solution to a major medical problem: the prevention of immune rejection responses to implanted foreign tissue. Human-to-human tissue transplants have been carried out since the 1900s. However, the implanted tissues can sometimes be rejected due to the recipient's immune response. Moreover, tissue transplants from animals like pigs to humans will almost certainly fail. Ingham and Fisher focused their work on the field of tissue repair and regeneration, and searched for some way to make tissues from both human and animal donors acceptable for implantation.
I was interested in looking at how we might treat tissues from human donors to make them more acceptable immunologically.
Soft tissue, like skin, consists of two basic components. First, the cells and DNA, and second, the so-called extracellular matrix, which, as the name implies, is located outside the cells. Cells and DNA differ from one person to the next. They're the biological basis for why every human being is unique. The extracellular matrix is like a scaffold that gives the body's tissues their specific shape. When foreign tissue is transplanted, the cells get attacked by the immune system. However, the extracellular matrix doesn't differ between people at all, nor does it differ very much between pigs and humans. So, as a result, it doesn't get rejected. Ingham and Fisher had an idea: to transplant only the extracellular matrix. Then it could be colonized by the body's own cells. And so, the researchers began a long phase of experimentation. Finally, with the help of washing drums like these, they successfully removed up to 95% of all cells from the tissue without destroying the extracellular matrix in the process.
The breakthrough step really was using this low concentration sodium dodecyl sulfate, because people had worked with this detergent previously, but they'd used much higher concentrations.
The difference between washed and unwashed tissue is clear, even to the naked eye. The tissue on the left contains cells, and the one on the right doesn't.
That's new. That's the inventive step that we have here.
Ingham and Fisher have developed their method further for different tissues and patented it. This gave rise to washed valves from the heart and cell-free cartilage from the knee, and decellularized skin that has already been approved for treating wound patients. It is grafted onto the wound and then colonized by the body's own cells. In 2006, together with other partners, the researchers founded the company Tissue Regenix to commercialize their invention. The company currently has a workforce of 80 people and an estimated market capitalization of over 100 million euros.
The key thing here is we can produce the decellularized tissues for many different applications and then essentially supply them to the hospital, to the patient, as an off-the-shelf product that the surgeon can just take there.
And this is what the skin patch to heal wounds looks like. Patient Rachel Sheets has already been treated with the decellularized tissue.
Day by day, you can see differences in it. It's changing, it's healing. I feel a lot better after the skin graft. And I had hope for the first time of getting it healed maybe and getting to go home before too long, and that made me feel good.
Patients around the world are already benefiting from the invention of decellularized tissue. It's a crucial step towards solving one of the biggest problems facing regenerative medicine today.